Linux and Fundamentals Part 6. This episode has 22 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. What is YAML used for? Here's a strong way to approach it. YAML is a human-readable data serialization format used to write structured configuration, Kubernetes manifests, Ansible playbooks, CI or CD pipeline definitions, because its indentation-based syntax is easier to read and write than JSON or XML. Nice. Let's continue. Question 2. What is a cron job? Here's a strong way to approach it. A cron job is a task scheduled to run automatically at fixed times or intervals, defined using cron's time-based syntax, minute, hour, day, month, weekday, on Linux systems. Great. Moving on. Question 3. What is SSH? Here's a strong way to approach it. SSH, Secure Shell, is an encrypted network protocol used to securely log into and execute commands on a remote machine, and is the transport Ansible and most server administration relies on. Alright, next question. Question 4. What is the difference between a process and a thread? Here's a strong way to approach it. A process is an independently running program with its own isolated memory space. A thread is a lighter weight unit of execution within a process that shares that process's memory with other threads, making threads cheaper to create but requiring careful synchronization. Let's keep going. Question 5. What is a zombie process, and how do you fix a system that has many of them? Here's a strong way to approach it. A zombie is a process that has already finished executing but still has an entry in the process table, shown as state Z, because its parent hasn't yet called wait to read its exit status. It holds no real resources beyond that table entry, so one zombie is harmless. A large number of zombies means the parent process has a bug, not reaping its children. The real fix is fixing or restarting that parent process. Since you cannot kill a zombie directly, it's already dead. Killing or fixing the parent lets the init or systemed process adopt and reap any orphaned zombies. On to the next one. Question 6. What is a file descriptor limit, limit, and how do you fix a too many open files error? Here's a strong way to approach it. Every open file, socket, or pipe consumes a file descriptor, and Linux caps how many a process can hold open via ulimit, a soft limit, what's actually enforced, raisable by the user up to the hard limit, and a hard limit, the ceiling, raisable only by root. A too many open files error means the process hit its soft limit. Fix it by raising the limit in or etc. or security or limits conf. The systemed units limit na file setting, or ulimit n in the shell, but also check whether the application is leaking file handles or connections instead of closing them, since raising the limit alone just delays the same failure at a higher ceiling. Good. Here's another one. Question 7. What is CPU throttling? Here's a strong way to approach it. CPU throttling happens when a process's CPU usage is capped, deliberately, by a container CPU limit, or by hardware thermal limits, and it's forced to run slower or is paused once it exceeds its allotted CPU time in a given period. Nice. Let's continue. Question 8. What is a message queue? Here's a strong way to approach it. A message queue is a middleware component, like pub or sub, RabbitMQ, or Kafka that decouples producers and consumers by buffering messages between them, enabling asynchronous processing and absorbing load spikes. Great. Moving on. Question 9. What is caching? Here's a strong way to approach it. Caching stores frequently accessed data in a faster-to-read location, memory, CDN, local disk, so subsequent requests can be served without recomputing or refetching from the slower original source. Alright, next question. Question 10. What is a monolith versus a microservice? Here's a strong way to approach it. A monolith is a single deployable application containing all functionality in one code base and process. A microservices architecture splits functionality into many independently deployable services that communicate over the network, trading simplicity for independent scaling and deployment. Let's keep going. Question 11. What is a typical CI or CD pipeline flow, stage by stage? Here's a strong way to approach it. A typical flow is: check out source code, install dependencies, run static analysis or lint, run unit tests, build an artifact, binary or container image, run integration tests, push the artifact to a registry, deploy to a staging environment, run smoke or acceptance tests, then promote, often with manual approval, to production, followed by post-deploy verification. On to the next one. Question 12. What is a Jenkins pipeline? Here's a strong way to approach it. A Jenkins pipeline is a suite of automated build or test or deploy steps defined as code in a Jenkins file that Jenkins executes as a single connected workflow, giving you version-controlled, repeatable CI or CD instead of clicking through freestyle job configuration in the UI. Good. Here's another one. Question 13. What is the difference between a Jenkins declarative pipeline and a scripted pipeline? Here's a strong way to approach it. A declarative pipeline uses a fixed, structured syntax, pipeline, stages, stage, steps, that's easier to read and validate but less flexible. A scripted pipeline is written in full groovy inside a node block, giving complete programmatic control at the cost of more complexity. Declarative is the recommended default for most teams today. Nice. Let's continue. Question 14. What is a Jenkins agent, node? Here's a strong way to approach it. An agent, formerly called a node or slave, is a machine, physical, VM, or container, that Jenkins connects to and dispatches build work to, letting the controller, master, distribute pipeline execution across multiple workers rather than running everything on one machine. Great. Moving on. Question 15. What are Jenkins plugins, and can you name a few commonly used ones? Here's a strong way to approach it. Plugins extend Jenkins with integrations and features beyond its core. Common ones include Git or GitHub plugin, Source Checkout, Pipeline plugin, Jenkins file support, Docker plugin, build or run containers, credentials binding, secret management, Blue Ocean, pipeline visualization, and Kubernetes plugin, dynamic agent provisioning on a cluster. Alright, next question. Question 16. What is GitLab CI or CD? Here's a strong way to approach it. GitLab CI or CD is GitLab's built-in continuous integration and delivery system, where pipelines are defined in a .gitlab CYML file at the repo root and executed by GitLab runners whenever code is pushed or merged. Let's keep going. Question 17. What is a .gitlab CYML file? Here's a strong way to approach it. The .gitlab CYML file is a YAML file at the root of a GitLab repository that defines the pipeline's stages and jobs, what to run, in what order, on what triggers, and with what scripts, which GitLab automatically picks up and executes. On to the next one. Question 18. What is a GitLab CI or CD runner? Here's a strong way to approach it. A GitLab runner is the agent process that actually executes the jobs defined in .gitlab CYML. It can be shared, GitLab hosted, or self-hosted, and picks up queued jobs from GitLab and reports results back. Good. Here's another one. Question 19. What is GitHub Actions? Here's a strong way to approach it. GitHub Actions is GitHub's native CI or CD and automation platform, where workflows defined in YAML files under GitHub or workflows or run in response to repository events, push, pull request, schedule, etc., on GitHub hosted or self-hosted runners. Nice. Let's continue. Question 20. What is a GitHub Actions workflow file? Here's a strong way to approach it. A workflow file is a YAML file under GitHub or workflows or that defines triggers, on, jobs, and steps. Each step typically either runs a shell command or invokes a reusable action from the marketplace or another repo. Great. Moving on. Question 21. What is a GitHub Actions runner? Here's a strong way to approach it. A runner is the server, GitHub hosted or self-hosted, that executes a workflow's jobs. GitHub hosted runners are ephemeral VMs provisioned per job, while self-hosted runners are your own persistent machines registered to a repo or org. Alright, next question. Question 22. What is the difference between Jenkins, GitLab CI, and GitHub Actions? Here's a strong way to approach it. Jenkins is a self-hosted, plugin-driven automation server that works with any Git provider and needs its own infrastructure to run and maintain. GitLab CI or CD is tightly integrated into GitLab itself. Pipeline defined in .gitlab CYML, runs via GitLab runners. GitHub Actions is GitHub's native equivalent, workflows in GitHub or workflows or, runs on GitHub hosted or self-hosted runners. Jenkins offers the most flexibility and plugin ecosystem, while GitLab CI and GitHub Actions offer simpler setup since they're built into the platform you're already using for source control. Let's keep going. That wraps up this episode. Nice work practicing, and see you in the next one.